LLaMA-Omni2, LLM-based real-time spoken chatbot with autoregressive streaming speech synthesis. 1. Introduction to LLaMA-Omni2. LLaMA-Omni2 is a speech-language model, SpeechLM, designed for real-time spoken interactions using large language models. It ranges from 0.5 billion to 14 billion parameters, utilizing the Qwen 2.5 series LLM as its core. Key features: real-time speech interaction, responds to speech inputs instantly. High-quality output, maintains fluency and naturalness in speech outputs. Efficiency, requires fewer resources compared to previous models like GLM-4 voice, despite training on significantly less data, only 200K dialogue samples. 2 types of SpeechLMs. SpeechLMs are categorized into A. Native SpeechLMs, directly convert speech into discrete tokens, use GPT-style decoder-only transformers, require vast speech datasets for training, millions of hours. Example, GLM-4 voice. B. Modular SpeechLMs combine a speech encoder and decoder around an LLM. Use less training data, thousands of hours, due to leveraging the LLM's inherent capabilities. Example, LLaMA-Omni2, which uses Whisper's encoder and CosyVoice 2 decoder. 3. Architecture of LLaMA-Omni2. Components: speech encoder, Whisper Large v3, converts incoming speech into encoded representations. Speech adapter processes speech encoder outputs using a downsampling module and a feed-forward network before feeding it into the LLM. Large language model, Qwen 2.5, the core component for generating text responses. Text-to-speech module, an autoregressive language model initialized with Qwen 2.5b generates speech tokens from LLM outputs. Flow matching and vocoder transforms speech tokens into MEL spectrograms and ultimately into audible speech using hi-fi GAN vocoder. 4. Speech understanding. Speech understanding involves converting speech instructions into text responses through speech encoder. Whisper encoder converts audio input into a sequence of representations. Speech adapter compresses and transforms these representations before feeding them into the LLM. 5. Streaming speech generation. Streaming speech generation synthesizes speech while generating text. Process: 1. Speech tokenization. Converts speech into discrete tokens using a finite scalar quantization method. 2. Text-to-speech language model, TTS-LM, receives fused representations, textual context, hidden states from LLM through a gating mechanism. Generates speech tokens autoregressively. 3. Chunk-aware causal flow matching. Generates streaming MEL spectrogram chunks from speech tokens. 4. Hi-fi GAN vocoder converts spectrograms into audible speech. Read-write strategy adopts an R-read-W-write strategy where every RLM outputs trigger W speech token generations, enabling simultaneous text and speech output. 6. Training procedure. The model is trained in 2 stages. Stage 1, separate training. Stage 1A, train speech-to-text, encoder, and LLM. Stage 1B, train text-to-speech language model separately without gate fusion initially. Stage 2, joint training. Integrates gate fusion module and jointly trains the speech-to-speech components, fine-tuning for end-to-end streaming capability. 7. Data construction. The training data involves synthetic, multi-turn speech-to-speech dialogues created by generating dialogues from LLaMA 3.3-70B instruct model, synthesizing speech instructions and responses using Fish Speech 1.5 and CosyVoice 2 0.5B models. 8. Evaluation metrics. The model evaluation covers spoken question answering spoken QA, accuracy in answering spoken questions, speech instruction following, assessed using ChatGPT scores. GPT-4o evaluates relevance, fluency, helpfulness. ASRR, consistency between speech and text outputs. UTMOS, speech naturalness score. Latency, speed of response. 9. Experimental results. LLaMA-Omni2 demonstrates superior performance over other models, surpasses previous models, GLM-4 voice, LLaMA-Omni, in accuracy and speech naturalness, maintains a low latency, 600 millisecond, ideal for real-time interaction. Scalable performance improves with larger LLMs. 10. Ablation studies. Examined factors affecting model performance. Gate fusion module, adaptive fusion of LLM hidden states and textual embeddings improves speech-text alignment. TTS pre-training. Streaming TTS pre-training instead of offline or from scratch significantly enhances performance. Read-write strategy, optimal combination R=3, W=10, balances low latency and high speech quality. Training data size. Multi-turn dialogue data, 200K samples, effectively enhances performance compared to single-turn data. Summary. LLaMA-Omni2 significantly advances real-time spoken chatbot technology by integrating robust speech understanding and streaming synthesis capabilities within a modular architecture. Its superior performance with fewer resources makes it highly efficient and practical for real-world interactive applications. Thank you for tuning in. Let us know in the comments if there's a paper or topic you'd like us to explore next.